Bismillahirrahmanirrahim. Assalamu alaikum students and welcome to another lecture on project management. I hope that you are enjoying this holy month of Ramadan, and as you know that in the previous classes we have started our discussion on developing project network diagrams. We have also discussed that what utility these diagrams bring into the overall management of the projects and why project managers need to develop these diagrams. Today we would actually expand on these very concepts and we would conclude our discussion on the construction and analysis of project network diagrams. And I'm very confident that after listening to my lecture, you would be able to construct a network representation of your project activities. You would also be able to understand that what are 4 types of activity constraints that can impact dependencies. We can also be computing late start, late finish for every activity in the network diagram. And you would also be able to understand what is meant by slack and how to calculate it. And at the end we would be developing a critical path using the slack time and the slack concepts that we would develop during this lecture. Before I'm going to start this particular lecture, I am going to make a request. Please pause this video at this point in time and get a pen and a pencil and a notepad. Without pen, pencil and notepad, you would not be able to understand my lecture today, because today's lecture is going to be going to include lots of computations and lots of quantitative calculations. So I request you to pick up a pen and a notepad and then start listening to my lecture from this point onward. Thank you so much. So before we start our discussion on how to calculate the latest start and latest finish time, as I have already explained you in the objective of this today's lecture, let us do a bit of a recap of the concepts that we have discussed in the previous classes. So in the previous class, we have calculated the early start and early finish of every activities and how to compute and how to add this early start and early finish in our project network diagrams. So in front of you is an example project network diagrams. There are 1, 2, 3, 4, 5 and 6 activities in this particular project network diagrams. Each and every activity has been identified by giving it an ID, and every activity has a duration. As you can see, activity A has a duration of 1, B has a duration of 3, D is standing at 5, F is standing at 3, E has a duration of 2 days, and C has a duration of same 2 days. So before we move forward, let us do a bit of a recap and calculate early finish and early start for each and every activity. So as we have concluded in the previous classes, the early start for this activity is going to be 1, and using this formula, the early finish for this activity is also going to be 1. So if we are going to calculate the early start and early finish of activity B, this activity is going to start from the 2nd day. So I'm going to write 2 here, and by using this formula, this activity is going to take 2 2nd day, the 3rd day and the 4th day. So the 4th day would be the end or the finish of this activity. The same procedure can be applied for this. This C activity is also going to start on day 2nd, and this is going to end on day 3. Activity D, because D activity has 2 predecessors, so we are going to start it on the 5th day, because the latest activity B is going to end on 5th day, and we need the output from activity B to start our activity D. So that is why we are going to start it at activity on the day 5th, as we have discussed in our previous classes, and it is going to take 5 days. So it is going to take 5 days. So 5th day, 6th day, 7th, 8th and 9th. So the end of this activity is going to be on the 9th day. Activity E can be started on the 4th day, because the C activity is ending on 3rd day. So activity E is going to start on the 4th day, and it is going to take 2 days. So it is going to take the 4th complete day and the 5th complete day. So it is going to end on the 5th day. Again, for activity F, we cannot start activity F before we get the output from both D and E. So we are going to start activity F on 10th day, because the output of activity D is going to receive, we are going to receive the output of activity D on the 9th day. So we can start activity F exactly on the 10th day. So also activity F is going to take 3 days. So the 10th day, 11th and 12th day. So the EF, or the early finish of the activity F, is going to be the 10 is going to be 12. So we have already calculated this example in our previous interactive session as well. I just recapped it so that you can so that it can freshen up in your minds, and now we are going to calculate that how we are going to compute the latest start and latest finish time reactivity. But before we are going to discuss what is latest, how to calculate it, latest start and latest finish, let us first of all analyze that what is meant by latest start and latest finish times. Now both of these are times of an activity that basically represents the latest time at which the activity can start or finish without causing any delay in the completion of the particular project. If we are going to finish a particular activity after the time that we would calculate by using latest finish and latest start time, we are going to delay the overall time, the total time the project is going to take. So that is why we need to complete that particular activity maximum at the latest finish time, or we need to start this particular activity maximum at the latest start time. So this is the information that latest start and latest finish provides. And then how to calculate both of these activities, how to calculate both of these times. So to calculate these times, you work backward in the network diagram. So if I can recall, in the previous example, I have started the computation from the very first activity, and then I kept on moving till the very end of the project network diagram. But in order to start the in order to calculate the latest start and latest finish times, we need to start from the very end of the project network diagrams. That is why it is also called backward pass, and calculation of early finish and early start is called forward pass. So we call it backward pass because we start computing latest start and latest finish from the very last activity on our project network diagrams. So the very first step is that you need to set the LF time of the last activity of the network to its calculated EF time. So the LF time of the last calculated activity and the EF of the last calculated activity is going to be the same. This is the rule number one. And then you can use this particular formula to calculate the LS of all the preceding activities. So the LF time of all the immediate predecessor activities is determined by the minimum of the LS minus 1 time units times of all activities for which it is the predecessor. So in order to calculate the LS and LF of all the preceding activities, we can actually use this formula. Let us compute and let us try to calculate the latest start and latest finish using exactly the same example. So in the previous example, we have calculated the ES and EF of all of these activities, and these are actually the same numbers that we have calculated in the previous slides. Now let us start and calculate the latest start and latest finish for each and every activity, and we are going to follow the rules. The number one rule is that we are going to set the LF of the last activity equal to the EF of the last activity. So the EF of the last activity was 12. So we are going to use the same number as the LF for our last activity, which is going to be the 12 again. Right, so we have calculated our very first latest finish, which is going to be 12, and then we can use this formula to calculate the LS of activity number F. So the formula goes like this, that LF of this activity is 12 minus duration of this activity is 3 plus 1 time, right? So 12 minus 3 we would have 9, or plus 1 we would receive 10. So the LS of this activity is going to be 10. Right, simple as that. Now as you move forward, as you move backward into this particular diagram, you would see that there are two predecessor activities for activity F. So how we are going to calculate? We are going to use the latest time, which means that we are going to use the LF of this activity in order to compute the LF of both of these activities. That is, the LF for both of these activities are going to be 9. right? The LF of both of these activities is going to be 9, though the ES of activity D is already 9, but we have the ES of activity E was 5, but we have still computed it as 9 because the predecessor activity has an LS of 10. So in order to compute the LS of both of these preceding activities, we need to look at the successor, and we simply have to minus 1 from the successor, and we can allocate the LF of both of these activities as 9, as you can see here. Now, as you know that we have calculated the LF, it would be very easy to calculate the LS by using this particular formula. If I can write LS here, we can use the same formula to calculate the LS for both activity D and activity E. So for activity D, the LS would be 9 minus 5 plus 1, which is going to be 5. And for E activity, we can calculate 9 minus 2, which would give us 7, and plus 1, 8. Right? So, okay. So now we have calculated the LS and LF of 3 activities. We have calculated the LS and LF of activity D, E, and F. Now we can actually move backward. Again, as you can see that activity D has 2 predecessors. It has a C as activity as a predecessor and B activity as a predecessor. Here again, we are going to use the LS of D to calculate the LF for both B and C. So the formula is going to be simple. We are just going to minus 1 from the LS of activity D, which means that for both of them, the LF is going to be 4. Now if we go move to activity B and we need to calculate LS, it is going to be pretty simple. We simply need to use the same formula, which is going to be 4 minus 3 plus 1, which is going to give us 2. And we can do the same for this 4, which is the LF minus duration for this activity, which is 2. The 4 minus 2, it would give us 2 plus 1, we are going to get 3. Right? Now the same, now if we come to activity number 1, in activity number 1 we have 2 succeeding activities. We have activity number B and we have activity number C. Now which particular activity we are going to use in order to compute the LF for activity A? So the answer is that that particular activity which has the least LS. So the least or the smallest LS is of activity B. So we are going to use the LS of activity B to calculate the LF of activity A. So the formula is again pretty simple: 2 minus 1. The LF for this activity is going to be 1, and using this particular formula, the LS of this activity is also going to be 1. So this is a way in which you can calculate the latest start and latest finish. Latest start and latest finish means that this particular time basically represents that you cannot start and you cannot finish a particular activity after this particular time. Which means that if I'm going to take this as an example, activity B as an example, if we are going to finish activity B after the 4th day, we are going to delay the complete project. So this is what the latest start and latest finish basically tells us. If we are going to start activity B after the 2nd day, it would delay the complete project. So in order, if we want to keep this complete project on track, if we want to keep this whole project online and on time, we need to complete activity B before the 4th day, and we need to start activity D exactly after the 2nd day. We cannot start the activity later than the 2nd day. So this is what the LS and LF actually tells us, and this is how we can calculate the LS and LF for each and every activity. I hope this example has helped you in order to understand the complete concepts in much details. You can actually pause this video at the moment and you can revise and recap all of these concepts. You can also do examples of your own, and then once you are clear, you can move forward to the next slides. Okay, so once we have computed the EF, the ES, the LS and LF for each and every activity, the time is right that now we need to calculate the critical path. So there are two methods that you can use in order to calculate the critical path of all of your project network diagrams. The first methodology is very, very complex. And if you would have such project in which there are lots of activities, this first method would be very, very difficult to to apply. So that is why I would be using the second methodology. But in order to explain you that what is the first method, let me give you a brief idea that how you can actually calculate by using the first methodology. So by using the first method, you need to identify all possible paths through the network diagrams, and you need to add up the duration of all the activities that lie along those paths. And the path with the longest duration time is the critical path. For example, if I take this previous example, there are lots of paths as you can see in front of this, in front of you. We have this path. We also have this path, and we also have this path. So if we basically have three paths. So if you need to calculate the critical path by using the first methodology, you need to calculate the duration of each and every activity that lies along each and every of these three paths. And then you need to add up all of these durations. And the path that has the longest duration, that particular path is the critical path. Now this particular methodology becomes a bit complex if you have lots of activities in your project management or in your project network diagrams. So that is why we are going to use the second methodology, which is the calculation of slack time and identifying the critical path using the slack time. But before that, let us first try to understand that what is meant by slack time. The slack time, which is many times also called float time. In many books and in many YouTube videos, you would see that the slack time is being referred as float time. Please do keep this thing in mind that both of these terminologies are exactly the same. You can use the slack time or you can use the float time as well. In my lecture, I would be using the slack time as the basic terminology to explain this very concept. So the slack time is basically the amount of delay expressed in unit of times that could be tolerated in the start time or the completion time of an activity without causing a delay in the completion of the project. So the slack time is basically the time by which you can actually delay a certain project and you would still complete a certain activity, and you would still complete project in its allocated time. If I can explain you again, slack time वो time है जिस पे अगर आप थोड़ा सा डिले भी कर दें एक्टिविटी को, तो you would be able to complete that project on the allocated time. That is, if you would even delay a particular activity by slack time, you would be able to complete the project in the allotted time. So that is meant by slack time. For example, right in front of you, there is a B activity and E activity, and these are both of these activities are the same activities that we have computed and calculated in the previous slides. So if you look at both of these activities, so in the B activity has an ES of 2 and EF of 4. It has an LF of 4 and LS of 2 as well. And the slack time that is being represented here is of 0. Shortly, we would also understand that how to compute this slack time. But at the moment, just try to keep this thing in mind, that what this slack time actually means. I'm just trying to explain you that what this slack time actually means. We would come to the computation afterwards. Same is for the activity E, which means that here the ES is 4, the EF is 5, the LF is 9 and LS is 8. Here the slack time is standing at 4. So this means that the B activity which had the slack time of 0, we cannot delay this particular activity. we need to start this activity immediately on the allocated day, which means that we need to start this activity exactly on the second day. If we would delay the start of this activity, we would delay the overall time of the project that we are going to accomplish. On the other hand, if we can compare activity E with activity B, here we have a slack time of 4, which means that we can start this activity on the 4th day, but we can actually delay this activity maximum by 4 days, which means that we can start this, even if we start this activity on the 8th day, which would be a delay of 4 days, we would still be able to complete the project on the same allocated time. Now, if I'm able to make you clear the concept of slack time, now let's try to understand that why this slack time is used, or why we use slack time, and then we would come to the portion on how to compute slack times. So the slack time actually gives us flexibility. It shows us that what are the activities that we can actually delay, what are the activities on which we need to allocate resources on priority. As you can see in this example, we need to allocate resources on priority on activity B. As far as activity E is concerned, we can delay activity E to a certain amount of time, which is mentioned by the slack of that particular activity. So this is what slack time is calculated for. Slack time actually gives us a sense of relief. It gives us a sense of flexibility that for completing certain activities, we still have time, and even if we can delay a certain activity by a certain time, we would still be able to complete the project in the given allocated time. But the priority should be given to such activities which have a slack of 0. So now let us understand that how we can compute the slack time for each and every activities. So if I can take the example of activity C. So activity C has an ES of beginning of day 2, and it has an LF of end of day 4. As you can see, it has an ES or early start of 2, and it has an LF of 4. Its duration is 2 days, and it has a day 3 window within which it must be completed without affecting the total duration of the project. Therefore, it has a slack of 1 day. When you choose to delay the start of an activity, possibly for resource scheduling reasons, first consider activities that have total slack associated with them. As I've already explained you, when we are going to compute a certain, when you are going to allocate resources, we are going to give priority to those activities that have minimum or that have very less slack. So activities that have more slack are much more flexible, and they can be scheduled in a much more flexible way. So how we can calculate the slack time? There are two types of slacks, and different project managers calculate slacks in different ways. Please keep this in mind that both of these formulas would give you exactly the same answer. So you can use both of these types of slacks. You can use finish slack that is calculated by using this formula, that is LF minus EF, or you can use start slack as well, which can be calculated using this formula, that is LS minus ES. So if we are going to compute the slack of activity C by using finish slack, we are going to take LF, which is 4, and we are going to minus the EF, which is 3, from this very number, and we would get 1, which is the slack time for this activity, which means that we can actually delay this activity by 1 day. We do not have to start this activity exactly on the second day. We can even start this activity on the third day, and even then we would be able to complete the whole project on time. But we cannot delay this particular activity more than its slack time. We cannot delay this activity for 2 days. We can just delay this activity for 1 day. This is the bit of information that slack time is giving. Okay, now let's discuss that how we can calculate the slack time. And in order to calculate the slack time, you do not have to follow any order, which means that you can start calculating the slack time from activity A, that is the very start of the project network diagrams, or you can even start calculating the slack time from the very end of the project network diagram, which is from the activity F. You can even calculate the slack time for the individual activities. Let's start the calculation of the slack time, and in order to calculate the slack slack time, you can use one of the formulas. Both of the formulas would give you the same result. So in order to keep things simple, I am going to use the first formula, that is I'm going to use the finish stack formula, that is LF minus EF. So if I'm going to calculate the slack time for the very first activity, which is activity number A, I'm going to take the LF of A and EF of A, and I'm going to minus both of these things, and I would get 0 as the slack time. For activity B, again I'm going to take the LF, which is 4, the EF, which is again 4, and the slack time that I would get is again 0. But if you look at activity number C, the LF here is 4, the EF is 3, so the slack time is going to be 1. For D, the slack time is also going to be 0. For E, the LF is 9 and the EF is 5, so the slack time is going to be 4. And for activity F, again the slack time is going to be 0. So this is how, very simple, it's a very simple formula, very easy way to calculate the slack time for each and every activity. So the thing is that how we can compute and how we can analyze that what slack time is telling us. So the slack time is telling us that there are certain activities on which we cannot afford any sort of delay, but in some other activities we can delay those activities by a certain amount of time. For example, we cannot afford delaying activity number A, B, D and F, because here we have 0 slack time, but we can afford to delay activity number C by 1 day and activity number E by 4 days, and we would still be able to complete this project in 12 days. So this is what the slack time is going to tell us, and this is a very useful and very important information for project managers, because now project manager have a certain flexibility that which activities are to be given importance, which activities are to be given priorities, and which particular activities can be delayed to a certain amount of time. The slack time also gives us this information that we have a certain flexibility in completion of these activities, but we cannot delay this activity more than these days, which means that we cannot delay activity E more than 4 days. The maximum delay that we can afford in this case is only the 4 days. So this is a very useful information, and I hope that I was able to communicate and convey to you how to calculate the slack time. So the objective of calculating the slack time was that we were discussing that how we can understand and how we can calculate the critical path. The critical path of any project network diagram is the path of those activities that are the most important activities, or that are the crucial activities of that particular project network diagrams. So now we have calculated the slack time. How we can use the slack time in order to identify the critical activities and then the critical path. So first of all, it's a very simple formula. All those activities that have 0 slack are critical activities. For example, here activity number A, B, D and F are the critical activities, and the path that the critical activities share is going to be our critical path, which is going to be this path. I am highlighting it by red. Now this path is going to be the critical path for our project network diagrams, because this is the path that is shared by all the critical activities of our path. So this is a bit more simpler way of calculating the critical path and the critical activities. You can simply calculate the slack time, and all of those activities that have a slack time of 0, all of those activities that have a slack time of minimum of 0, and the path that is shared by those activities is the critical path for that project network diagrams. So why we develop project network diagrams? We develop project network diagrams to estimate the total time that this project is going to take, and what are going to be our critical path and our critical activities, which means the activities that are the most important to complete this project on time. So once we have completed, or once we have developed this whole project network diagrams, two situations are bound to come up, or two kind of situations the project manager is going to face. The one situation is most favorable to the manager, and that is the initial project completion date meet the requested completion date. But usually this is not the case, but it does happen sometimes that the date that you have calculated by using project network diagram is actually the requested date as well, which means that in this example that I have just shown you, our project is going to take 12 days, and the client has also given us the 12 days to complete this particular project. In this scenario, we are in a very favorable situation, and we can directly move toward the implementation of our planning phase. But in most of the situations, this is not the case. In 95% of the project the project managers in the project manager's life, the project network diagram always comes up with a date that is a much more that is always a date that is later than the completion date. For example, again, if I take the example of this project network diagram, so this project network diagram is telling us that this project is going to take 12 days. But what if the client has told us, or the client has requested, that this project needed to be complete in 10 days? What we are going to do then? So this is a situation in which most of the project managers, they find themselves, and this is the question that I have been asked in the previous interactive session as well, that what we would do, or what we should do, if the project network diagram is telling us that a particular project is going to take a certain day, which is more than the requested date or the requested day from the clients. So what you can do, you can actually compress the activities. What is meant by compression? Compression basically means that now you need to use time in a much more efficient way if you want to reduce the time that you have calculated using project network diagrams. And how you can do it? There are certain steps you need to follow. Number one, you should analyze the network diagrams to identify areas where you can compress the project durations, and you need to look for pair of activities that allow you to convert activities that are currently worked on in a series into more parallel pattern of the work. Or you can also work on the successor activities, and you can calculate that when they might begin once the predecessor activities has reached a certain stage of completion. So you can do multiple things. You can start pairing certain activities, which means that instead of using finish to start dependency, you should be starting start to start, or you should be using start to start dependency. Or you can also identify that what is the level of a predecessor activity, or what is the certain time at which the predecessor activity is still going on, and you can still start the successor activity. In order to do that, you need to identify such activities that are partitionable. Partitionable activities basically means that such activities that can be divided into certain subgroups. As it is mentioned here, a partitionable activity is the one whose work can be assigned to more than one individual, and that can actually do that activity parallel or simultaneously. For example, I have given you an example of again from a construction point of view. For example, painting a room is partitionable. How we can develop parts of painting the room? If one person can be assigned for each wall, when one wall is finished, a successor activity like picture hanging, like finishing that particular paints can be done on the completed wall. In that way, you do not have to wait until the room is entirely painted before you can begin decorating the wall with pictures. So this can be a very good example of how you can actually start doing certain activities simultaneously. So instead of waiting that once the complete 4 walls are painted, only then you are going to decorate, you can start decorating the wall. You can assign the walls to 2 or 3 different resource persons, and once one particular wall is completed, you can start decorating it, and the rest of the people were still completing the paints in the other on the other walls. By this way, you can actually decorate a wall while not waiting for the entire room to be painted. Another example can be of a software development program. So as you know, and if anyone has a background of software development, every software is basically developed in batches. So instead of waiting that once the complete software has been developed, only then we can start testing, we can actually start testing once one particular batch or one particular subset of a program is completed. In this way, the design of the program and the testing of the program can be run simultaneously. Many a times project managers basically face pressures from the external environment. For example, you are a project manager that is working in an organization, and that organization is working on launching a certain project, and you also know that your competitor is also working on the same project with similar features, and you and your competitors are kind of in a race in which which particular organization is going to bring that project, that particular product first in the market is going to succeed. In such situation, you cannot actually wait by having finished to start dependency on each and every activity, and you cannot actually afford completing one activity at a time and then moving your resources and allocating resources to some other activity. You need to complete activities simultaneously, and that is why you need to work very smartly, and you need to pair certain activities. You need to identify activities that can be divided into subsets, and you need to complete these activities by allocating more resources. So the idea is to convert finish to start activity dependencies to start activity dependency, and this is the way you can actually start both the activities at the same time, and you can finish these activities exactly at the same time. Another way that you can actually use in order to develop some sort of a buffer, or in order to develop some sort of flexibility in your project network diagrams, is to use management reserve. What is a management reserve? Management reserve is a buffer time that we add in our estimation to adjust for the delay. For example, we know that a particular activity will require 3 days of our time to complete, but instead of submitting 3 days, we submit an estimate of 4 days, which would give us an additional of 1 day. This 1 day is going to be our buffer so that we can complete the activity with much more flexibility. But you please keep this thing in mind that Parkinson's law basically tells us that Parkinson's law states us that the work will expand on to the time slotted to complete it. So if you are going to give wrong estimations, maybe you would start procrastinating, maybe you would become lazy, maybe you would become lethargic, and instead of an activity that can be completed in 3 days, you are taking more than 3 days, which is now you are going to take 4 days. So many times it happens that management reserve is added to add a certain flexibility, but instead it is taken for granted, and that particular activity is completed in the very last minutes. So this is not a very good strategy to follow. So the better strategy is that you need to stick with the 3-day estimate, and you need to work to make it happen. This is a much better strategy than using management reserve and making your team members lazy and procrastinating on the same activity. So as in the previous classes, we have discussed very important concepts of dependencies. And while discussing dependency models, we have discussed that there are 4 different types of dependencies that organizations and project network diagrams can actually use. We can use start to start dependency, start to finish dependency, start to start dependency, and finish to finish dependency. So there are 4 different types of dependencies that we can use in order to develop and in order to design our project network diagrams. But many a times there are certain situations in which there are some constraints, or in which there are some limitations on how we are going to design our project network diagrams. These constraints or these limitations are called management constraints, technical constraints, sometimes inter-project constraints, and date constraints. So constraints are basically limits on dependencies that you can use. That is, many times you can't use a dependency you want to use, but 2 activities because of the constraints. So constraint basically means even if you want to use finish to start dependency, you can't use it because of a certain constraint. There are 4 types of constraints that can happen. We have technical constraints, management constraints, inter-project constraints, and date constraints. Let's talk about technical constraints. Technical constraint basically means that technical dependency or technical constraints happen between activities when there are those that arise because one activity requires output from other activity, and before work can begin on it, in the simplest case, the predecessor must be completed before the successor can actually begin. For example, if you want to start, for example, if you are working on a construction project and you want to construct a roof over a certain room, if you have not completed the 4 walls, you cannot start constructing the roof over that particular room. So even if you want to want to start this work simultaneously, you can't do it because there is a technical constraint. There is a fixed output that you require in order to take as an input in some preceding activity, and you need a certain activities to be completed so that an activity can actually start. Such constraints are called technical constraints, in where we are basically bound to use finish to start dependencies. We cannot use any other dependency rather than finish to start dependencies, because in case of technical constraint, we need some input from a preceding activity in order to start a future activity. Now there can be multiple different types of technical constraints. The most common is discretionary constraint. Discretionary constraint basically means that they are judgmental calls, or they are judgment calls by the project managers that result in the introduction of dependencies. For example, a project manager has hired, if I can take the example that I was using in the previous lecture of a team who was collecting data and a team who was entering the data. Let's say we are very much limited on resources, and there are just 2 people who are collecting the data and who are also entering the data. If you remember, in the previous examples, we have tried to use the SS dependency or start to start dependency. That is, while we are collecting data, we are also entering the data. But what if the manager believes that the team who is responsible for collecting data and entering the data are new, they do not have the experience, they do not have the expertise, and we cannot rely on them for both the activities. So instead of expecting a very high quality of work from them by allocating both of these tasks, let us allocate them just one task at a time, and once they have finished gathering information, only then they are going to enter that particular data in the software. So here we have, though we want to use SS dependency, but we are still using the FS dependency, because here the manager believes that the team who is responsible for both of these activities is maybe not expert enough, and it is better for the whole project that FS dependency is used rather than SS dependency. Another technical constraint can be best practices constraint. Best practices are past experiences and that have worked well for the project manager, or are known to the project manager based on the experiences of other in similar situations. As I have given you example in the previous classes, that many a times organization is facing lots of pressures from the external environment, and though a manager wants to use FS dependency, manager has to go for SS dependency or start to start dependency, which means that they have to start both the activities simultaneously so that they can complete the project on time. So many a times managers have experience of certain dependency, and they only use their dependency rather than experimenting or adding more risk into your whole project network diagrams. Another dependency or another constraint that can occur is unique requirement. Sometimes both or 2 or 3 activities requires the same equipment. If that particular equipment or that particular human resource is busy completing one activity, that resource or that particular person cannot be allocated to some other activity. This is a unique requirement. So as it is written here, these constraints occur in a situation where a critical resource or of say an irreplaceable expert or a one-of-a-kind piece of equipment is involved in several project activities. So if you have just one if you have just one particular equipment to complete a project. For example, you have two program developers that are working on developing a software, but you only have one PC. Both of these program developers, they cannot work on the same PC. They have to reschedule. They have to start working when one particular project manager has stopped working and using that particular piece of equipment. So these kind of constraints are called unique requirements. Even in this situation, we cannot use SS dependencies, because both of these program managers or both of these program developers, they cannot start using the computer at the same time. When once would finish, only then the other can start working on the same computer. Another type of dependency is management constraint. As I've already told you that many times management is facing a pressure from the external environment, and though the management wants to follow the FS dependency, they have to follow the SS dependency because they need to finish a certain project in time. But what is the difference between management constraint and the constraint that we have discussed in the previous slide, which was the discretionary constraint? So the basic difference is that the technical constraint or discretionary constraint, they cannot be reversed. You can actually reverse the management constraint. For example, maybe you and your competitor is actually racing to launch a particular project, and both of these this actually have is forcing you to follow SS dependency rather than FS dependency. But suddenly you have come to know that your competitor has completely dropped the idea of launching that particular product. In this case, you can actually relax on developing that particular product, and you can again start following the FS dependency rather than the SS dependency, which you were following in order to complete that project in less time. So this is the only difference. You can actually reverse the management constraint, but you cannot reverse the technical constraint. Another constraint that managers can face is inter-project constraints. Inter-project constraints basically means that inter-project constraints basically results when deliverables from one project are needed by another project. So here, the deliverable, as you know, that every project has certain activities, and every activity is producing an output that is acting as an input for other projects, for other activities in that projects. But in many situations, as we have discussed in the very first chapter, that combination of lots of projects becomes a program. So in a program, lots of projects are basically working in one unified or one particular direction. So in that situation, an output of one project becomes an input for other projects. So in this particular constraint is called inter-project constraints. Such constraint results in dependencies between the activities that produce the deliverable in one project and the activity in the other project that requires the use of those deliverables. For example, the construction of the Boeing 777 took place in a variety of geographical dispersed manufacturing facilities. Each manufacturing facility is defined a project to produce its part. To assemble the final aircraft, the delivery of the parts from separate projects had to be coordinated with the final assembly project plan. As you can see, in order to complete or in order to construct Boeing 777, you need to receive parts from all different geographical dispersed construction plants and construction projects, and you can only start assembling Boeing 777 when you have received all the parts. So this is kind of the constraints that we discuss in inter-project constraints. Another constraint that managers can face is date constraint. Date constraints basically means that a date constraint imposes start or finish date on an activity that forces it to occur according to a particular schedule. For example, you can actually give a date that activity B cannot start before 10th of June, or activity B cannot finish before 11th of January, or activity B should finish on 6th of June. If you are going to impose these kind of dates or these kind of schedules on each and every activity, then we would say that you are using date constraints. And date constraints can actually take three different types. You can use no early then, which is that this day constraint specifies that earliest date on which an activity can be completed. If you are going, as I have given you example, if you are going to say that activity B cannot be finished before 5th of June, you are basically saying that you cannot finish activity B before 5th of June. Or you can say that no later than. This date constraint specify a date by which an activity must be completed. Or you can also use on this date constraint, that is this date constraint specify that exact date on which the activity must be completed. So if you are going to say that the activity B is going to finish on 5th of June, you are basically saying that activity B should not be finished before 5th of June, or it should not be finished after 5th of June. It should be finished exactly on the date that you have mentioned in the schedule. So these are different types of date constraints that you can also use in your project network diagrams. But by using all of these constraints, you and especially date constraints, the project network diagrams becomes very, very complex, and that is why it is suggested that you should not be using specially date constraints, because when you put date constraints, you are going to make your project network diagrams very, very inflexible. So this brings me to end of today's lecture, and mashallah, we have covered lots of very important topics in today's lecture. We have concluded our discussion on constructing our network representations of project network diagrams. Today we have not only discussed how to calculate the latest finish or early finish, we have also recapped the early start and early finish, the latest start and latest finish of each and every activity. We have also tried to understand that what are the constraints that can impact the operations of a project network diagrams and the working of a project manager. We have also tried to understand that what is meant by slack and how it can be calculated, and at the end we have used the slack time in order to compute the critical path and critical activities. So this brings me to end of today's lecture, and also to this particular chapter. I am expecting that you would be able to develop project network diagrams for your own activities and for your own projects. This is going to be the assignment for the next interactive session. You need to select one activity, one major activity, and you need to identify all the sub activities that are part of that major activity, and you need to develop a project network diagram for that particular activity, and you are going to present it in the next Wednesday, not on the coming Wednesday, not on coming Thursday, but on the next Thursday. Your final projects are also final project presentation is also coming near. So I am expecting that at this point in time you have planned your activities, you have planned your projects, you have developed your WBSs, you have identified, you have estimated your project time, you have estimated the resources required, and you have also estimated the cost. And after the completion of this chapter, you would also be able to develop the project network diagrams for all the activities that are part of your complete project. I want you to take very good care of yourself and your elder ones and your younger ones. Have a very, very nice day. Allah Hafiz.